So now we're going to move on to the second page in our summary sheet packet, which is on constant velocity. And we're going to do the exact same thing we just did with the at-rest summary sheet. So remember, constant velocity means that the distance changes by equal amounts during each time interval. So what is the acceleration when you have a constant velocity? Do you remember? So our acceleration is going to be 0. And our velocity is going to be constant. It could be any number. So when we plot these, the distance will be a straight line, but it won't be horizontal. And the velocity will be a straight horizontal line. So let's take a look at some data and go through this. So this is one part where you're really going to need to focus and try not to rush through it. So I want to consider the purple data first. So the distance increases by +2 in each time interval. The distance goes up by 2. And that means, just like what we were doing with the data, 2 minus 0 divided by the time is going to be the speed. Remember, speed equals distance divided by time. So that is going to be that our velocity is equal to +2. But when we plot this distance versus time, we're going to get a sloped line. It's very shallow because +2 is kind of a slow velocity. But when we plot the velocity, it's going to be +2, and it's always going to be +2. And that's going to be a fairly low line down here. It's going to be pretty low on the close to the axis. And recall that the acceleration equals 0 because the velocity is never changing, okay? So for the purple, I put some numbers in here. I've got a fairly shallow line, and my velocity is fairly low number here. So let's take a look at the blue data. Now this time I've increased my distance a lot, so I'm going up by 200s each time, so that the velocity will now equal 200. So now when we plot the distance versus time, it's going to be another sloped line, but it's much steeper because the velocity is actually a lot larger than the previous one. And when we plot our velocity versus time, again, it's going to be a horizontal line, but it's going to be 200. So it's going to be up here, higher value than what we had before. And acceleration, which is change in velocity divided by time, which is the same as our slope, and that equals 0. So if we look at these, we can actually take the slopes of our lines here in our distance versus time and come up with our data for the velocity versus time. So here our slope, which is very shallow, which is 2, the change in y versus the change in x. Remember, your slope, change in y over change in x, is 2 over 1. And so we end up with a velocity of 2 over 1. And for this blue line, which is much steeper, we get 200 over 1. And that's why we get this velocity up here. So this data is all related. And you can obtain the information about the other graphs just by looking at one. So we're going to look at some of these, and we're just going to kind of keep on working and practicing on this. So with the next ones, I did the same thing with some yellow and red. So yellow, I only had it going negative. So our distance ended up going -2, -4, -6, -8. And we ended up with a fairly small value of 2, -2 for our velocity. And I did a similar thing with the red data. I went up by -200. And I didn't draw these exactly at 0 here, just so you could see the difference. So this one also is down here at a higher value, even though it's negative. So if we think about these blue and purple have positive slopes. If we remember back from graphing and from math, those have positive slopes. And so they have positive velocities. These yellow and red have negative slopes, and they have negative velocities. So how the slope is going to be very similar to what the velocities are. And again, all of these are going to have accelerations equal to 0 because there is no change in our velocity. It's constant velocity. So pause that, think about it, digest it a little bit, make notes. This is part of the challenge for a lot of students, is trying to understand all of these. But don't overthink them and don't make them too hard, okay? So let's go on to the rest of the page once you've done all that. So what do we already know about forces for constant velocity? And the net force, and what type of equilibrium, and what do you have to have for your free body diagrams? You should hopefully know most of this or recall most of this. So you're still going to have balance forces. Your net force is going to be equal to 0. And this time your equilibrium is going to be dynamic instead of static. And hopefully all this looks familiar. And then your free body diagram should look very familiar to you. They're balance forces. So what is different here from what you had with your at rest summary? Hopefully you recognize that the type of equilibrium is really the only thing that is different. We had static for at rest, and here we have dynamic, but everything else was going to look pretty much the same. So ticker tapes. So what do they look like for an object moving at constant velocity? Are you going to have lots of dots or one dot? Hopefully you answered lots of dots. So if it's constant velocity and it's starting off over here on the left, what kind of spacing do you think you should have? Equivalent spacing, equal spacing. So you're going to put a number of dots and they're going to be equally spaced. The closer they are together, the slower the velocity would typically be. And the farther apart they are, showing they traveled farther during that time interval, the faster it's going to be. So I just did these and did them at kind of equal spacing, just to have an idea. And then I have, here is my overall summary sheet. Please use these, make notes on them, put whatever is helpful to you on them. These are going to be good references for you moving forward. So I'm going to return with the next video with speeding up.